So in 4.2, we have what's called binomial probability distribution. So again, in for these types of problems, there's a couple of criteria. One is there's got to be this either yes or no concept. Either it happens or it doesn't happen. So there's two outcomes. Now there's also a probability of success and the probability of failure going on. So those are the main two things that we have to pick up on in a probability thing. So question 16 is a type of binomial probability distribution. So if we look at this, 35% of the consumers prefer to purchase electronics online. You randomly select 8 consumers. Find the probability that the number of consumers who prefer to purchase electronics online is exactly 5, more than 5, or at most 5. So got 3 different questions here. So again, what we pick up on is either you prefer to purchase electronics online or you don't. So that's kind of how each one is. The other thing is each person is independent of the other person. So they're not influenced by the other person. So when choosing these 8 people, there's a 35% chance a person is going to have purchased electronics online. Now, our question is, what's the probability exactly 5 of these 8 purchase electronics online? So this becomes a binomial distribution. I'm going to do this example using Excel. So our number of people that we are doing is 8 consumers. So if I go to Excel, we have N is going to equal this 8. The next thing we pick up on is the probability. So 35% chance of them purchasing electronics online. So our probability, we're going to put down 0.35. There's a 35% chance of that happening. So notice that since there's 8 consumers, we have these outcomes. Of these 8, none of them shopped online. 1 shopped online, 2 shopped online. So what we can do is make a list of trials from 0 through 8. So here I'm going to put 0 and 1. Now I think the shortcut is if you kind of block these in. Oops, try that again. See how they just made that turn to a 0. So if I highlight both of these and then drag, it should count. So we want 0 through 8. So these are going to be our x's. So x could be, what's the probability that nobody chose electronics online? What's the probability of 1 person of the 8 purchases electronics online? All the way down to what's the probability that all 8 do online? Notice that there's a 35% chance that a person is going to be buying electronics online. So it's not a huge likely event. So to do our probabilities, so like what's the probability of 0? So what's P of 0? What I can do is use a formula in Excel. So if I hit the equal sign and type in binomial distribution, BINO, notice that we do have a binomial distribution formula. So if I click on that, it wants numbers, trials, probability, and then cumulative. So right now, we're saying 0 people chose to shop online. That's our X, that's our variable. And then the trials, we have 8 people altogether. The probability of an excess is going to be 0.35. So notice how I'm separating these by commas. Notice the last part is cumulative. We don't want this to be cumulative, so we're going to put false here. FALSE, so we're not going to include that. So if we hit enter, it should give us in our binomial probability. So it's saying about a 0.031 or 0.032 chance of that happening. So a little bit over a 3% chance of that happening. Now, what I can do is make a formula out of this. Now, my formula, what I can do, pick up on that. Instead of doing it that way, let me try this back again. And you hit equals to binom. Now, instead of typing the numbers in, what I can do is type in the fields. So notice that the number 0 was actually an A3. So if I hit A3 there, comma, that's going to tell me my number. My trials is 8. So that's going to be B1. So if I do B1 there. Now what I want though is I want this B1 to be locked in. So dollar signs lock in the B1 so it doesn't change. So if I put a dollar sign before the B and a dollar sign before the 1, it'll lock that in. So the 8 stays in the problem. The probability of 0.35, we don't want that to change either. So that's going to come from D1. But again, I want dollar signs here. So a dollar sign will fix that. It won't change. Oops. And then we do not want this to be cumulative, so we say false here, so it won't add. So if I enter, now I actually have a formula. Now what I can do is click and drag, and it should take us on down through here and do our probabilities. So the probability of 5 would be this 0.081. So the probability of exactly 5 would be this 0.081. The probability greater than 5, so greater than 5 means 6, 7, and 8. So if I do the sum of those, so I'm going to come down here and hit equal, and then sum. And I want to drag this 6, 7, 8 in there. Close my parenthesis off. So that'll add those probabilities up. So that's going to be 0.025. So the probability of that would be 0.025. And the probability of less than or equal to 5, so less than or equal to 5, again, is going to be 0 through 5. So let me go back to that. So notice how more than 5 would be greater than 5. At most 5 would mean 5 or less, so less than or equal to 5 is where those are coming from. So more than 5 means you got to be greater than 5. At most 5 means you have to be less than or equal to 5. So less than or equal to 5, we need 0 through 5. So if I hit the sum here, then I can drag in 0 through 5, and it'll add those up for me. Hit enter, and then it'll give me that probability of 0.975. So 0.975. So what this is saying is, since there's a 35% chance of them shopping online, the probability that it's going to be less than 5 or less, there's a 97.5% chance of this actually happening. So, because we're not seeing a huge percentage shopping online to begin with. So that's kind of a way we can do the problem using Excel as opposed to the calculator. So there are some advantages to Excel, but you still got to manually put the data into the calculator. So feel free to watch that video again, see if that helps you out. And again, there's other videos out there on YouTube that you can use as well.